Today, what I'm going to do what I want to talk about today was wood-fired kilns.
Welcome to the Potter's Roundtable, a monthly podcast where we share our passion for the ceramic arts and a collection of topics specific to potters. Remember to subscribe so you don't miss a single episode. Enjoy the show.
Okay, construction details, just some more just details about different kiln construction. There are basically two, and this is current designs, there are really two different types or two different categories of kilns that people build now, either flat-topped or they have some kind of an arch. And so there are different ways you could build some kind of a structure and basically just have a flat roof, and it could be slabs of insulation or bricks bonded together, something like that, or some kind of an arch structure. And there are two kinds of arches, catenary and sprung arch. A catenary arch and a sprung arch. A catenary arch is a self-supporting arch. I've built gas kilns and wood kilns, and there isn't a bit of cement or steel or anything in the whole kiln. It's completely self-supporting, and they typically look like that. So that might be the arch, and then I'd have it over a base, and then maybe somewhere either here or outside I'd have a firebox, but this is the wear chamber. It's a catenary arch. And the easiest way to visualize a catenary, this is actually a mathematical curve, a catenary. And the easiest way to think about it is, if I take a chain and I just hang it between 2 points, the chain naturally forms a catenary. And so you just flip it over. And the structure, the way because of the arrangement of the chain, it's a self-supporting arch. A sprung arch is not self-supporting. So I don't need, if I build a catenary, I don't need any support to hold it up. It's completely self-supporting. A sprung arch, I do. A sprung arch, I might have a kiln chamber that looks like this, and I have an arch that looks like that. This would tend, when this wants to be pulled down by gravity, which means the ends want to go out, I have to have some kind of support here to restrain the ends. And if I can support the ends of the arch, then the center doesn't drop. But I need some kind of side support on the arch, because otherwise this wants to drop and it wants to do this. It wants to flatten out. So as long as I can support this with some kind of let's say a metal framework typically, then the arch will stay up. But this is not a self-supporting arch. But so typically you'll see kilns that, in this case, I've got more of a box-like wear chamber with just this slightly curved roof, whereas with the catenary, I had the whole chamber itself had the curved roof from the arch. And generally, I think these arch kilns are more common than flat tops, and generally they're going to be one of these types, either a catenary arch or a sprung arch type for the wear chamber. And then the shelves would be stacked in here. But there are one of the nice things about a catenary arch is, by having this curve, it's a good design for a flame, because depending on how you orient it, the flame will naturally follow, for a downdraft, the flame will naturally follow the arch curve. So I don't have any dead corners. If I have a sprung arch and I have a low arch, this is kind of a dead area as far as gases moving through it. Whereas if I have a catenary arch, the flame naturally can follow the curve. And it's a great design, for instance, for a downdraft design, to have the flame come in here, rise up, be guided by the shape of the arch, and then exit again at the bottom. One of the things to think about in terms of constructing a kiln, if you're building a kiln, if you're ever building one, is generally, and it sounds a little weird, you start with the shelves and build out. If you're planning on building a kiln, the best way to do it is figure out what kind of loading space you want or shelf space you want and what the shape of the shelves is, and then you build the kiln to accommodate that. It's much more efficient, because if you're going to be buying shelves, and assuming you are, let's say, silicon carbide shelves, they're only available in certain sizes. And so you need to think about what do I want my loading space, how much space do I want, and what do I want the arrangement to be? Do I want it to be a square stack? Do I want it to be a long stack? And then you design the kiln around the shelves. And this is one of the big mistakes I've seen that people build when they build a kiln, and then they try to fit shelves into it afterward, and they're only available in certain sizes unless you want to cut them, which you can do, but it's not as efficient. So it really, I found, works better is build the kiln from the inside out. Think about the shelf the loading space you want and the arrangement, and then think about what kind of kiln what kind of effects, we'll talk more about this, what kind of effects you want the kiln to produce, and then design outward. Different kiln designs produce different kinds of effects with wood. They don't all produce the same kind of wear. So you also have to think about what kind of work do you want to produce. In terms of materials, one of the issues with wood kilns is they all need to be made with dense or hard fire bricks. You know, there are two kinds of bricks basically that are used to construct kilns, what are called insulating fire bricks, which are these light, sort of crunchy, very lightweight bricks. And they're great insulation, but they don't resist ash at all. They'll dissolve in the ash. So basically, at least the interior, the whole interior of a wood burning kiln has to be made out of hard bricks or dense fire bricks. The problem, and they're great because they're strong, they're also expensive, but they're great structural bricks. But the problem is also they're terrible insulators. They're horrible insulation. You need them to resist the ash because the ash from the wood is going to land on everything in the kiln, and if you get hot enough, it'll actually melt, or at least the ash will melt, and it reacts with everything that it touches. So if it lands on the bricks, it'll actually start attacking and eating into the bricks. At least it'll coat the bricks, if nothing else. So you've got to use hard bricks, which again, and the problem, and they have to be high temperature bricks. Typically you want something that will resist, they're what are called high alumina bricks. Aluminum oxide, the nickname for it is alumina, that's aluminum oxide. And if you get bricks that are high in aluminum oxide, they tend to resist the corrosion or the attack by the ash. So you can't just use any kind of bricks to build a wood kiln. You have to use sort of more specialized kind of bricks to build the kiln. And at the same time, they're terrible insulation. So the other thing is just about construction details as far as the kiln is, if you're thinking about building one, you need a shelter. You need a shelter over the kiln to protect it from the weather. And you also need a shelter. If you're going to have firewood, you need some place to store your wood. So you need a shelter, someplace to store your wood so that your wood stays dry. One of the reasons why you need the shelter over the kiln, among other things, is the fact that if the kiln is exposed to the weather for a long period of time, the bricks will absorb water, and then you can blow up your bricks when you heat up the kiln. The face of the bricks will blow off if you heat it up too fast, and it takes a long time. The bricks they look dense, but they can still absorb moisture slowly, and you have to heat it up for a long time to drive that heat back out, or the water back out. And in most cases, you won't get it out. You'll blow your bricks. The faces blow off. So the thing with that is you don't want to let your kiln get wet in the first place, which means you need a shelter. Part of the kiln structure is you need a shelter over the kiln. Okay, just some information, just some miscellaneous sort of things about operating a kiln. One of the different features about firing with a wood kiln is you can't put all the pots right on the shelves. All the pots are generally supported on what are called wads. And if you haven't seen wads, I'll pass these around. These are used wads. They're just little pellets of clay. So every single pot you load into the kiln is supported on some kind of little system of wadding or something to keep it up off the shelf. And the idea is these are made out of different mixtures of things, but the idea is if these stick to the pot, you can knock them off the pot if you have to, or you can grind them off the pot, but they're relatively soft. They don't get as hard and dense as the rest of the clay, so they're removable. They're also they're disposable, basically. Because especially like Mike's talking about, if you get a lot of ash collecting on your shelves, your pots would just be glued to the shelf. Okay, so you have to, if you haven't seen them, I'll pass those around. You have to use some, and there are all kind of recipes out there for different wadding mixtures, and everybody claims they got the best wadding mix, all that kind of stuff. So that's one feature about wood firing is this is another step you have to do. You have to prepare the wadding, and then all the pots are supported on wad in. And so if you have pots, for instance, that have lids on them, then the pot is supported on the shelf, and then the lid is separated from the pot with wads. And you have to think about, depending on the size of the piece, how you're going to support it. If you don't have enough wads and the clay starts to soften in the firing, it'll droop. So you have to think about how many wads do I need under the piece and the size of the piece to properly support it, because you don't want it to sag and sort of bend over the wads, especially with platters, for example. Yeah. Another point in terms of operation is, I alluded to this before, stacking has a really big effect on the flame path. And this is part of the art, frankly, of wood firing, is learning how, with a particular kiln, how do you arrange the pots in terms of size and width and proportions and the spacing between the shells. Because basically what you're doing is the flame is coming into the wear chamber and then you're guiding it in certain directions. And if you want it to go past a certain pots or over a certain pots in a certain way, then you do that by spacing the shelves and spacing the pots and the size of the pots. And so if I know I have a kiln, for instance, where I tend to get the draft wants to go and I get a hot spot, I might actually put more pots there and slightly block it and cause the flame to go somewhere else. So I can deflect the flame by putting the pots in there, or if I have open channels, I can get the flame is, the other thing is, you'll see a lot of discussion, I've seen a lot in some articles, they talk as if the flame has a mind of its own. The only thing the flame wants to do is it's going to get out of it's going to take the shortest possible path to the exit. And so all you can do is to sort of divert it and slow it down and make it move around, and don't let it take the straight shot to the exit. But in any kind of a kiln, that's what the flame is going to do. It's going to come in and it's going to head for the exit as soon as possible. And so by moving the pots around and changing the shelf, I'm preventing it from maybe making a straight shot. I kick it up higher in the kiln, or I move it around. And so you're controlling that to a huge extent by how you load your kiln. And this is really an art. It really takes some experience with a kiln to learn what's the best way to load this kiln. Where do I get the best results in the kiln? By how do I stack it? Okay. Generally, with wood kilns, you preheat the kiln in some way. And actually, what you really want to do is you want to preheat the chimney, because you want to, if you're just going to start a wood fire, you need to have this draft to pull in to get the fire to burn. So I've seen people typically they'll put like a propane burner in the kiln and run it through, and they're not so much doing it to heat up the wear, they're using it to heat up the chimney so that they can get a draft. So you'll stick a propane burner in there. It can even be like a weed burner. I use a little raku burner, and I heat up my chimney, and then once I have enough draft, then I can start to build a fire that's where I'm actually burning the wood. Other people might just build a small campfire, like in there, like outside the kiln or near the entrance, and let that gradually, burn and heat up the chimney so that they start to develop a draw. It's the same way, like if you have a fireplace. You need to start a small fire initially to start some hot air, gas moving up the chimney, to start the draw, and then as the draw improves, you can add more fuel, and then as that burns, it gets hotter, you can add more fuel, and then the size of the fire can increase. But generally, you need some way to preheat the kiln. And depending on the kiln design, you may have to do more or less preheating. If it's a downdraft, then you've got to do more preheating, because if you think hot gases want to rise, well, if I've got a kiln chamber where I'm making the gas come back down before it can go out, then I've got to create enough draft to pull it back down. So I really need, with a downdraft chamber, I definitely need to preheat the chimney to be able to pull it out. Otherwise, the gases just accumulate in the chamber, and the fire won't burn efficiently. And so generally with a wood-fired kiln, you can increase the size of the fire and the amount of the wood as the draft improves. And what this leads to then at some point is you establish what some people call, what you call a stoking cycle. For every kiln, you go into some kind of a rhythm that's best for that kiln, as to how much fuel do I load, how often do I put it in. And because what you're trying to do is you're trying to get the best amount of heat out of it, and you're trying to keep the temperature to continue to rise. And that's, again, this is part of the art, is knowing how much fuel to put in and when to put it in. If I put in too much fuel, it chokes the fire, and it might almost go out. If I don't put in enough, it'll burn, but it'll burn very quickly, and I might not get a heat rise. Every time I put a shot of fuel into the kiln, it burns, and I get a surge of heat, and then the heat sort of dies down as the fuel is dying down. So I've got to get more fuel in there again to keep the fire going. So part of what you're doing is, when you're firing this, is establishing this stoking cycle. How much wood, and it depends on the size of the wood, what kind of wood it is, and how often I put it in. In terms of, again, going back to this operation, the kiln design and the size of the kiln, in terms of the heating rate, how fast you can heat the kiln up, the kiln design itself and the size of the kiln limit the heating rate, basically. I mean, really, really big wood kilns, you simply can't heat them up quickly. Because you can't get them hot enough. So the structure of the kiln itself limits how quickly you can fire the kiln. I'm a firm believer in that there's no reason not to heat up the kiln really fast. I'm not single firing. Single firing is where you don't do bisque firing. You put the pots in and you're essentially doing a bisque firing in the early part of the firing. Have you all heard of that term, single firing or once firing? But where you're bisque firing, I've never seen a problem with heating it up fast. I did a firing years ago where I started stoking at 8:30 in the morning and I was at cone 10 at 10:30. And there were no problems at all. So to me, it was bisque fire. But to me, I want to heat up the kiln as fast as I can because nothing's happening while I'm heating it up. I'm just heating it up. So I want to get up to high enough temperatures where I can start to melt ash and start to get some flashing and start to get some effects. And then I can slow it down. But the ability to do that depends to a great extent on the design of the kiln. If I don't have an efficient firebox, if I don't have an efficient kiln design, no matter how much fuel I put in there, I simply can't raise the temperature quickly. So the kiln design has a big effect on my ability to heat up the kiln quickly. And then when you're actually stoking in a wood kiln typically, is everybody familiar with the term reduction? This is basically where you're burning a fuel, but you don't have enough air to completely burn on the fuel. And the only reason why you fire in reduction, really, is color. That's the only reason to fire in reduction. Because everything else is the same, essentially. So you're looking for different color changes in the clay and different glazes and ash effects and flashing and so forth. So when you're firing a wood kiln, typically, when you do a stoke, you go into a very heavy reduction before that wood actually sort of catches fire. And you're cooking the flame. And then when it catches and it's burning vigorously, then you go into a lighter reduction. You're getting more efficient burning. So typically when you're firing a wood kiln, you're going between heavy reduction and lighter reduction. Every time you stoke, you go into heavy reduction and you get a lot of smoke out of the chimney. And then it sort of clears and the wood really catches and burns. And then you get the most heat and then you go into a lighter reduction. So you're not even usually heating in constant state of reduction or oxidation. It's alternating. It's going heavy, light, heavy, light, heavy, light, depending on as you stoke. So you sort of get a wavy heat rise. Because when you're burning the fuel inefficiently, when you're not burning it completely and you're in heavy reduction, then you're not getting the most heat out of it. Generally one of the things you're also doing when you're firing a wood kiln, you're trying to balance heat rise with reduction. Because in order to get reduction, by definition, you're not burning the fuel efficiently, right? You've got excess fuel and not enough air. So you're not getting the most heat out of it that you could, but you're getting the reduction atmosphere, which is what you want. But in order to get the heat rise, to get the temperature to climb, you can't be in super heavy reduction all the time or the temperature wouldn't go anywhere. So one of the tricks of firing a wood kiln is you're trying to balance a certain amount of reduction and yet still get enough burning that the temperature continues to rise. And that's one of the sort of the tricks of firing any wood kiln is that balance. Is how do I keep reduction or get enough reduction, but still get temperature rise? I can get temperature rise really fast if I essentially produce oxidizing conditions and just have a ton of air in there and I burn the fuel really quickly. I might not get good reduction. I can get a great heat rise, but I won't get good reduction. And in a lot of cases, people want the reduction as well, not just the heat rise. So the reduction in the heating rate, just kind of, I mentioned already, are affected by the stoking cycle, the timing even, the type and the size of wood, the amount of wood, and the air inlet control also is. In order to fire a wood kiln efficiently and properly, you need to control the air. You don't just let in any amount of air that wants to go in. You have to have openings that you can control it, increase the amount of air or let it down or decrease it. And so that's another important feature of kiln design. You don't just have an open area where the air can just rush in. You have to have openings that you can close or partially close to control it. And all of those affect the heating rate and the amount of reduction you get. One good feature, though, about wood kilns in general is you can combine them with salt and soda firings, and this is fairly common. A lot of times what people will do is if they have is everybody familiar with salt or soda firing? The idea was you put salt, sodium chloride, or soda in, and you get these other flashing effects and glazed fluxing effects. So this is fairly common if you have a multi-chambered kiln, is to have the first chamber, let's say 2 chambers, the first chamber will be pure wood, and the second chamber will be salt or soda. And so that's a nice feature about wood or gas, but you can have salt or soda combined with it, especially in a multi-chambered kiln.
We hope you're enjoying the show. please take a moment to leave a 5-star review on your podcast platform of choice. It really helps new listeners find the show. Don't forget to subscribe to receive updates as new episodes are released. And if you'd like to support the video and podcast production of the Potter's Roundtable, become a patron. Go to patreon.com and search for the Potter's Roundtable. Your support will help us achieve our goal of creating a digital library spanning the ceramic arts for use by educators and artists alike. Thank you for your support. Now let's get back to the show.
And the last thing just to mention is, in terms of firing, is that you also, when you finish the firing, you have to close up the kiln really tightly, because you don't want to pull air in and reoxidize a lot of especially some of the flashing effects. You can really lose them. Flashing is this surface coloration. You like, this is flashing on a pot. And you can lose that, you can reoxidize it. And so one of the things at the end of a wood firing is you need to be able to clam up the kiln really tightly so that air doesn't get pulled in, especially when it's really, really hot, and produce some reoxidation effects, whether you have glazes or not. Some common firing problems that people run across. Stalling. And actually, it's interesting because this is actually a natural phenomenon that you're fighting. This is a law of physics that you're actually fighting. This isn't the fault of the kiln entirely or your fault entirely. And the fact, this has to do with actual physics. The hotter you heat something up, the faster it wants to lose heat. And so as I'm heating up a kiln, I'm throwing heat into the kiln, and heat is being lost from the kiln. It's coming up the chimney, it's going out the walls, it's going out all the holes. And the hotter that kiln gets, the faster that kiln wants to lose that heat. So I'm running a race up a hill, and as I get higher up the hill is getting steeper. And I have to run harder and harder and harder, and I have to stoke faster and faster and more wood, because the higher it gets, so in a sense, if I didn't compensate for it, all kilns would naturally stall, because they get up to a certain point. If I'm putting in the heat at a certain rate, at some temperature, that rate is not going to be enough to keep the temperature going, and it's going to stall. That's just the law of physics. You can't get around that. Now, electric kilns get around it, especially these electronic controllers. They take that into consideration, and they're programmed in knowing that the kiln is losing heat faster and faster as it gets hotter, so automatically the controller puts in more heat and stays ahead of it. So that's essentially what you're doing when you're firing a wood kiln or a fuel burning kiln. Is you have to stay ahead of the fact that the kiln is losing heat faster and faster and faster. And so this thing we call stalling, it is a natural effect that occurs, that you're fighting. And what you're balancing is, this is where I mentioned, you're really balancing then reduction versus temperature rise. I've got to continue to get enough heat to come out of the wood to keep the temperature moving, because a lot of it's being lost constantly, but I'm still trying to keep it in reduction maybe. And that's the struggle. Is that how do I keep it in reduction? How do I keep enough burning so that I'm overcoming the heat loss and the temperature keeps going up? And one of the tricks to this is is called reading the fire. Is knowing when to look into the firebox and knowing when to stoke. And this you have to learn by looking at your kiln. For every particular kiln it's different, and it depends on the wood you're using and so forth, but when you put in some wood, you stoke, and it catches fire and it burns. When do you put in the next load of wood? That's something you have to learn for how your kiln responds. And it depends on the size of the wood and the type of the wood. But this is part of your stoking cycle, is learning when do I put in that next. If I put in too much wood too fast, I'll choke the fire. It won't burn, it won't catch. And in the meantime, the kiln is losing heat like crazy. So while the wood is trying to catch fire and burn, the kiln is dropping in temperature because it's losing heat. So it's kind of like I've got to keep pumping the heat in there at just the right rate to keep the temperature moving up. The minute I stop pumping that heat in, the temperature will stop or actually drop, and that's the stalling that people talk about. And this is another case where also the kiln design is very important. You can get, I've seen some kilns that from the minute they were built, they had problems with stalling because either the firebox wasn't big enough or they didn't allow enough air. All these other features contribute to that. do I have are the openings for the air big enough to give me enough air when I need it? One of the things that's not about to think about with a wood kiln or any kiln when you're burning something is it always is a good idea, I think, to have the openings bigger than they need to be. You can always close them back up, but you can't open them up once you built the kiln. So if you have air holes, you have lots of air holes, and you have maybe even more than you need, that doesn't matter. You can always block them off. But if you get to, I've seen kilns that didn't have enough air inlet, and they're getting to a point where they need to burn a lot of fuel, and they simply can't get enough air into the kiln to burn all the fuel, and the kiln stalls, and it never reaches temperature. So all these things, the kiln design is really important. Is the firebox big enough? If I have a huge chamber like this, the size of this room, I'm going to need an enormous firebox to put enough heat in to heat up that kiln. So just, is the firebox big enough just to heat up that kiln? So these things are all important. If not stalling, another thing sometimes you can get is slow burning or failure to reach temperature. You just can't quite get it up there. It could be the things like the chimney height. The chimney might simply not be tall enough to create a strong enough draft to pull in enough air to burn all the wood you need. And the chimney will only get so hot, and then, which means that it will only pull in a certain amount of air, and that's it. It's done. That's all the air it can pull in. Well, that might not be enough air to burn all the fuel that you want to put into the firebox. So if the chimney isn't tall enough or large enough, that could limit the burning rate. Or as I mentioned already, if you don't have enough air inlets, that can limit the burning rate. If I can't get enough air into the kiln, I'm putting wood in there, but there has to be enough air to burn all that wood. And if I can't get that air in there, that can limit the burning rate. The wood can also be too large. The size of the wood matters, because if you think about it, wood is only burning on basically it's coming off the surface. And if I put in a couple of huge chunks of wood, that's going to catch fire and burn a lot slower than that same amount of wood broken up into little sticks. Well, yeah, ultimately I'll get the same amount of heat out of it, but the rate I get it out of it is important, because if it takes too long for that wood, that big chunk of wood to burn, the kiln drops in temperature because it's losing heat. It's kind of another analogy I think of sometimes is like you have a flat tire and you haven't patched the leak and you're trying to pump up the tire. And the more you increase the air pressure, the more the air leaks out of the tire. And so you've got to keep pumping faster and faster and faster to get any air to even stay in the tire. That's kind of like what it is when you're firing the kiln. You've got to keep putting heat in faster and faster and faster because it's being lost faster and faster. The other thing that can even come in is things like, how dry is the wood? Wet wood is really expensive in terms of firing a kiln because it takes a lot of energy to heat up water. And if you're throwing wet wood into the kiln, the first thing that's going to happen is I'm going to heat up that water before the temperature of the kiln will rise. I've got to heat up that water. That takes a lot of energy. So even if the wood is damp, that can slow down the heating rate because I'm wasting heat heating up water rather than heating up wood. And that can vary a lot. Another thing that people run into a problem is inefficiency or high wood usage. You seem like you're using an awful lot of wood. Well, I guess this goes back to firebox design and the size of the firebox. It also goes back to the overall construction of the kiln and the arrangement and the insulation of the kiln. Again, these hard brick kilns are horribly insulated, but even different shapes of kilns lose heat faster than other shapes. And a box kind of kiln will lose heat slower than a long tube because there's more surface area. So for the same amount of wood, a boxy shape is more efficient than a long tube in terms of heat loss from the kiln. So it's going to take me more heat, I'm going to have to put in more heat to heat up a tube design than I will sort of a box design. And also too much air. There's actually such a thing as too much air. Aside from oxidation or reduction, it takes a lot of heat to heat up air. And so if I'm putting in a lot more air, letting a lot more air into the kiln than I need to burn the fuel, I still have to heat up that air. And so I'm wasting fuel heating up air, aside from whether even I care about the oxidation or reduction. So excess air can actually hurt the heat rise. Another problem that is hot and cold spots in a kiln, and this is very common with wood. and it also is very common depending on the kiln design, is that with any kiln, it's hard to get uniform heating of the whole kiln, the wear chamber, but it's also it really is influenced by the kiln design. And it's also influenced by the stacking, because as I mentioned before, once you've got your kiln built, you're done with the kiln design. But there are things you can do in terms of stacking and other little barriers and things you can put inside to redirect the flame. So how you direct the flame with stacking or with fake partial walls and barriers inside the kiln, you can sometimes counteract some of these natural hot and cold spots. As I mentioned, like if you have square corners on a kiln, square corners tend to be cold spots because they tend to be dead spots. So anywhere you've got a square corner, the flame does not want to go into all the way in and then turn and then go out. It'll just skirt the corner. So if I have the corner, this could be either looking at a kiln or down at the kiln. The flame is not going to do that. The flame's going to do that. So this is not getting as much of the flame as if it was a curve. And part of this is the fact I've got a long flame again, so that's part of the kiln arrangement, is where is this flame reaching? How have I redirected the flame? Another problem that you see sometimes in wood kilns is unmelted ash. And again, some people like the crusty look on the pots, and other people don't. If you don't like it, I mean, I like to use glazes in wood firing, and so I don't want a lot of crusty ash. And one of the problems could be either the temperature is not hot enough so that the ash didn't get a chance to melt, so you were still accumulating ash on the pots and it didn't get a chance to melt, or the late stoking was too violent, that you're throwing in wood and you're stirring up the ash and you're creating a lot of ash too late in the firing to allow enough time for that ash to melt. Because the ash will stick, once the pots get hot, the ash will stick to it, but you have to know enough time for that ash to melt in place. And so if you're accumulating ash and it's sticking to the pot right up until the end of the firing, and you're not allowing enough time then for that ash to melt without new ash landing, you can end up with crusty pots. And then the last thing, I got a couple more things, but then the last thing would be pots slumping in the firing. And this basically is the choice of the clay. When you're firing with wood, you've got to pick clay bodies because you're never going to fire to just cone 10. So you've got to pick clay bodies that can take much higher temperatures than simply cone 10, because chances are they're going to see temperatures higher than cone 10. And if not, they're going to slump. So why fire with wood? Well, currently there is renewed interest in wood firing. Actually, we're going through kind of a renaissance right now in wood firing. There's really renewed interest in it. Some people I know fire just because they like the sense of history, and they like, there's sort of a low-tech simplicity kind of associated with wood firing. Depending on where you live, it might be a cheap or a readily available fuel. Maybe, that. There's the aesthetic effects. A lot of it is, personally, I like the wood fire just because I like fire. And I like the sort of I like the idea that you can have this destruction, and out of this destruction can come something beautiful. And I sort of like that. So I sort of like that. But I just like the destruction. But then, and you get the flashing effects and ash accumulation and ash deposits. So there are a lot of aesthetic effects that are kind of unique to wood firing. And then also, I think there's also the serendipity effect that with wood firing, there are a lot of opportunities to have wonderful accidents happen that, and there's a saying that's interesting. It goes back to like electric firing, where people say electric firing is great because it's so predictable, and electric firing is terrible because it's so predictable. And so that's the good thing about wood firing, is there are a lot of opportunities for sort of things to happen that you didn't anticipate, and a lot of times some wonderful things to happen. Also some horrible things to happen, but that's another feature of it. Okay, the last thing I had, well, a couple of more things, and then some disadvantages of wood firing. First of all, firing is a lot of work. It's a lot of work. Preparation, you've got the preparation of the fuel and storage of the fuel. You've got the preparation of the kiln. Typically, you want to clean it out between firings. You've got to prepare it. You've got to kiln wash the shelves and the posts. You've got to prepare the wadding, and you've got to do the wadding. The actual effort of firing itself can be a big effort. The kiln, unlike gas kilns and electric kilns, the fire needs constant attention. You generally don't walk away from a wood firing. And you often, frequently, it's not uncommon, you need a crew, So it's unusual if one person can fire a kiln without some kind of a help. So you need a crew to fire, and long firings, you need shifts. So this is more planning for the firing. And long firings are very common. I mean, it's unusual to have a firing that's less than 12 or 24 hours or something like that. Usually, they're days usually. The firing actually can be dangerous. The stoking, depending again on the design of the kiln, stoking the wood in the firebox can be really, really hot. In some cases, you need protective gear, but it can be pretty dangerous actually in terms of the heat exposure. So that's another thing. And then the cleanup. There's a lot of cleanup involved after each firing. Just cleaning the site, cleaning the wood. You've got to empty out the ash pit. Cleaning the kiln. So there's a lot of work involved in wood firing. In terms of building a kiln, in terms of disadvantages or things to consider, you need a suitable location. You need a place where it's a little bit, I wouldn't put one in a place where I know I've got steady winds, for instance, that are going to blow down my chimney. I want it protected somewhat. The bricks are expensive. These refractory bricks are $3 to $4 per brick, and you might need thousands of them. You're going to need thousands of them to build a kiln. I just built a kiln a couple of years ago, and they were $3.75 per brick. And also, the bricks are not good insulators. So you at least have to line the kiln with these bricks that will not be eaten away by the ash, but they're also horrible insulators. The furniture the kiln furniture, the shelves and the post has to take high temperatures. You can't assume that you're only going to go to cone 10. So you need to make the posts and the shelves have to be out of something that can take the high temperature. And you must have a chimney, generally. You're not going to probably build an updraft. So you're going to have a chimney. The last thing I had here was just a few points to remember in sort of generalities. First of all, if you're firing, you want to select clays for two things, for temperature stability, but also for their response to the flame. Like if you're interested in flashing, certain clay bodies will flash and produce these colors really well, and others are absolutely dead. I do a lot of tests just because of my background, and I've got some clay bodies that at cone 11 and 12 do nothing. They come out looking like concrete. And so there's a lot of variability in clay bodies in terms of their ability to respond to the flame and acquire these flashing colors. And so if you're interested in that, that's a consideration. Not just the temperature, but what's the capability of the clay to respond to the flame? The other thing is that in general, when you're firing with wood, most pots are not completely glazed. One of the whole points of firing with wood is to look at these effects of the flame on the clay, in the Barrett clay. So if you're gonna completely glaze your pots, the question to ask is, why are you wood firing? If you're gonna glaze every inch of the pot, why are you firing with wood? Because you're missing out on a big part of the effects. Again, these are points I mentioned before, but I'm kind of summarizing here. The pot stacking really has a huge effect on the flame path, so that's something you need to learn in terms of stacking the kiln. The stoking cycle is really important in terms of getting heat rise and in terms of the amount of the wood and how often do you stoke and how much do you stoke. And it can even, I've had a kiln that I was firing a while back where it even mattered whether I crossed the wood or didn't cross the wood when I put it in the firebox. If I didn't cross the wood, then essentially I was making one big block of wood. So when I was stoking, it was very important to cross the wood as I was stoking it into the firebox to make sure that all the parts of the wood were exposed to the flame. If it all just lay parallel, then all these pieces were essentially just making a big log in the firebox. So just depending on, I could see the difference in the heat rise depending on how much I crossed the wood or didn't cross the wood in the firebox. And along with that is paying constant attention, especially if you're new to the kiln, and reading the fire. And there's two things you can do is look at the fire in the firebox and get used to the idea is when is the optimum time? How fast and how much is the wood burning? When do I put in the next load? And also look at the chimney. What's coming out of the chimney? If I've got really heavy, dense black smoke coming out of the chimney, then I'm in reduction, and I probably don't want to put in any more wood at that point. When the chimney starts to clear and the smoke is dying down, then it means the wood is catching, and then I'm getting closer to the point where I can put in more wood. So you're looking at the fire in the firebox, and you're also looking at what's coming out of the chimney. So read the fire and read the chimney. And as I mentioned before, if you're building a kiln, you want to plan the construction based on the available shelves or the stacking space you have in mind. How much work do you plan to fire? What shelves do I have available? And you want to base it on that, the stacking space, and also the form of the available fuel. You've got to think ahead about what kind of fuel are you likely to get. I knew a guy that built a kiln that fired wood pellets, and he could cut the pallet, and he could put a whole pallet in the firebox. So his firebox door was a slit that was a little over 4 feet wide, and he'd shove a pallet in there, and that was his fuel. And he knew that when he built the kiln. So that part of this is think about is you're not going to build a wood kiln and then go looking for fuel. What's your wood source likely to be? Because that might determine the shape of the firebox or the design of the kiln. Another important thing to think about if you're thinking about building a kiln is different kiln designs do different things. For instance, there's a design of kiln called a train kiln because it looks sort of like a train, like a steam engine. And typically, it'll have a chimney, and then there's a long tube, and then there's some kind of a firebox here, either inside and the firebox is here, and the flame goes like this through the work and then up the chimney. And the top of this tube, or the top of this long coffin-like structure, lifts off, and you load the pots typically down through the top. And these kilns I hate them because I think they're horribly, at least with this kind of a firebox, they're horribly inefficient, but they give great ash. They produce because the ash is dropping down, you get a high. So if you like a lot of ash on your pots without excessively long firings, this is a great kiln for it. If you're firing pots with a lot of glazes, this is probably not a kiln design you want to use. So one of the things to think about is what type of work do you want to make? Because that can affect the choice of the kiln design. And different kiln designs yield different effects in terms of ash and flashing and so forth. Okay? Couple of, just in terms of kiln design, things to remember also is that preheating the air really improves the efficiency of the kiln. So if you can, you'd like the air coming in to pass over the coals at the bottom of the firebox before it actually gets to the wood. Because if I've got cold air hitting the wood, before anything can happen, I have to heat up the air. So I'm wasting fuel heating up the air. Well, if I have coals sitting in the bottom of a firebox, just lost my microphone here. If I have coals sitting in the bottom of the firebox, if I can pass the air over the coals, then that'll be much more efficient. So a typical design, what might be, if here's the inside of a kiln, and here's my grate, and my wood is sitting on here, and here's my pots, and the chimney is this way. If I can have my air intake, here's a pile of coals that fall down from the grate in the bottom of the firebox. And if I can have the incoming air passing over the coals, so before it even hits the wood, it's gotten heated up, I'll get much more efficient burning because I'm using the coals to heat the air. So if I can design the fire, and then this passes into the kiln, if I can design the firebox like that, it's much more efficient than having just cold air coming in and hitting the wood. Much more efficient. And I also need to have, this way also, if I control the size of these openings, that gives me the control of the amount of air that I'm coming in, as well as preheating it. And the other thing I mentioned already also is different types and sizes of wood have different effects. They burn at different rates. Pine, for instance, burns a lot faster than oak, but ultimately pine doesn't yield as much heat as the same amount of oak. So the pine will burn faster and kind of give you an explosion of heat, but it doesn't. By volume, it doesn't. A cord of oak will yield a lot more heat than a cord of pine, but not as quickly. So the type of wood also has a big effect on it. And the last thing, as I mentioned before, is you also remember if you're going to build a kiln, you need a shelter for the kiln, and also a shelter for the wood. You need to protect it from the weather. We know that this was a lot of information in a short period of time, so if you want to hear it again, listen to our podcast version of the presentation. Search for the Potter's Roundtable on your favorite podcast platform.
The Potter's Roundtable is brought to you by Washington Street Studios and our patrons. If you enjoy the show, please subscribe, give us a 5-star review, and tell your friends. If you want to learn more about Washington Street Studios and shared studio memberships, please visit our website at www.hfclay.com. Thank you, and we'll see you again next time on the Potter's Roundtable.